which I will review for you in a minute, but for right now, I'm just going to write down the result of integration by parts just so we don't get lost in the weeds. And so the integral of t to the 3t is 1/3 t to the 3t minus 1/9 e to the 3t plus c. Now, the only thing I have left to do is to get y by itself. So I divide both sides by e to the 3t. So these cancel, and we end up with y equals. So now I'm going to divide this e to the 3t into each term of the numerator. So I have 1/3 t minus 1/9 plus c e to the negative 3t. That's the same thing as c over 3 to the t. So there we go, general solution. Now I'm just going to confirm that that is the same solution I get if I use lucky guess. So in lucky guess, we start, it's a 3-step process. You start by solving the associated the associated homogeneous differential equation. So I start by solving dy dt equals negative 3y. I'm just ignoring this t here. And that is a quickie separation of variables. You get y equals k e to the negative 3t. That's my y homogeneous. Okay, step 2 is to find one particular solution to the differential equation, the original differential equation, which I think I'm going to write like this. dy dt equals negative 3y plus t. So the forcing function is a t, so that means my y particular guess has to be linear. So I'm going to guess that y particular is alpha t plus beta. And then I have to take the derivative. Y particular prime would be alpha. And then I'm going to plug into this differential equation and see if I can find an alpha that will make it true. So dy dt, that's alpha, equals negative 3y, so negative 3. My y particular guess is alpha t plus beta, and then plus t. Distribute the negative 3, and I get negative 3 alpha minus 3 beta, minus 3 alpha t minus 3 beta plus t. Combine like terms, and I have alpha equals negative 3 alpha plus 1 t minus 3 beta. And now I equate coefficients. So I should have a t term and a constant term on both sides. So my constant term on the right is negative 3 beta, and my constant term on the left is alpha. They have to be equal. Negative 3 beta has to equal alpha. And then I have a t term on the right, but there's no t term on the left. We can just assume there's a like zero t term on the left. So it has to be that 0 equals negative 3 alpha plus 1. Okay, so the 0 equals negative 3 alpha plus 1 only has an alpha in it, and you can solve for it, and you get 1/3, which means that negative 3 beta equals 1/3. So beta is negative 1/9. So y particular has the format of my guess, alpha t plus beta, and I now know what alpha and beta are. So my y particular is 1/3 t minus 1/9. So there's my y particular, and there's my y homogeneous, and y general is the sum of the two. Y general is going to be k e to the negative 3t plus 1/3 t minus 1/9, which is exactly what I got over here. I named the arbitrary constant something different, but it's essentially the same solution.